The next standard we will be working on is NBT.2.4, which is adding and subtracting multi-digit whole numbers fluently. So we're going to first start with a concrete model using base 10 blocks to represent 438 plus 175. I already modeled these problems, so it doesn't take me too long to pull all of them over, and we will just understand the concepts at this time. So I started by dragging out 4 hundreds blocks, 3 tens blocks, and 8 ones blocks. Then I added 1 more 100 blocks, 7 more tens blocks, and 5 more 1 blocks. Over here on the right side of my screen, I'm going to follow this along with the standard algorithm so we could connect this concrete model to our standard algorithm. So I'm always going to start in my ones place when I add, and now I'm going to be bundling up some of these because there is more than 10 there. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I could bundle these ones up and replace them with another 10 rod. So I'm going to take these ones away, move them over here, and I'm going to bundle them for the 10 rod. So now I have a 3 in the ones place, and I added 1 10 block to the tens place. Next, I'm going to count up my tens and see if I could do any bundling in this category. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I could take these 10 and switch them out for 100s block. So I'm going to move them back over to the side. I'm going to move 10 tens, and then I will exchange it for the 100. Bring over 100. Now I'm going to count my hundreds and see if I could have any bundling here. 100, 200, 300, 400, 500. No bundling there. So now I'm going to put these all together. I have 5 hundreds, 1 10, and 3 ones for a total of 513. Now if I come over to my standard algorithm, when I do 8 plus 5, I get 13. So I'm left with 3 ones, and I bundled one of my tens up to here. I represent that by putting a number 1 above the tens place. So that means 110. So now 110 plus 3 tens plus 7 tens is 110. So I'm going to keep 110 in the tens place, and I'm going to put 100 above the hundreds place. So now I have 100 plus 400 plus 100, which would be 513. I'm going to clear my whiteboard and come to the next problem. This one is going to be a subtraction problem. I'm subtracting the number 504 minus 356. When I do subtraction problems, I only represent the first number and I take away the second number. So I modeled 504, and now I'm going to take away the second number. So I'm doing 4 minus 6. Well, I only have 4 ones to take away, so I know that I cannot do that. So what I'm going to have to do is I'm going to have to unbundle. I would like to unbundle one of these tens, but I don't have any tens. So I'm going to have to unbundle one of the hundreds. So I'm going to have to put one of these hundreds away and take out 10 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Once I have 10 tens, now I'm able to unbundle one of these tens, put that back, and take out 10 ones. 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I have 16 ones. 14 ones, excuse me. I had 4 plus 10 more would give me 14. Now I could easily take 6 away by saying 1, 2, 3, 4, 5, 6. Okay, next I'm going to take away how many tens I need to take away. I need to take away 5 tens. 1, 2, 3, 4, 5. Lastly, I need to take away 3 hundredths. 1, 2, and 3. So I'm left with 100, 1, 2, 3, 4 tens, and 1, 2, 3, 4, 5, 6, 7, 8 ones, for a total answer of 148. Now let's connect that over to the standard algorithm. 504 minus 356. Whoops. Ignore that very long 5. 4 minus 6 I could not do. I couldn't take away 0 from tens, so I had to unbundle one of my hundreds. Now I only have 4 hundreds left, and I have 10 tens, which equals 100. But I still need something for my 4, so I have to cross out the 10. Now I have 9 tens left, and now I'm left with 14 ones and 9 tens, just as we did in the model. 14 minus 6 is 8. 9 minus 5 is 4. And 4 minus 3 is 1. So my answer is 148. Next, we're going to get into larger numbers. So this one is 19,930 plus 3,548. So I have lots going on here. So in the ones place, I have 2, 4, 6, 8 ones. Perfect. I don't have to group anything. Next, in my tens, I have 10, 20, 30, 40, 50, 60, 70. 70. I don't have to bundle anything there either. Let's go to the hundreds. 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. Oh, there's 1,000. 10 hundreds equals 1,000. So I'm able to bundle up all these hundreds to get 1,000. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I could bring one more 1,000 up to here. Now I have 1, 2, 3, 4 hundreds. So now I'm able to move over to my thousands. Let's see if I could have enough to bundle to make a 10,000. 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000. So that's enough to make one 10,000. So I'm going to bundle 10 of these away. 2, 3, 4, 5, 6, 7, 8, 9, and 10. So now I'm left with 3,000s, and I bundled it for one of the 10,000s. So I'm left with 2 10,000s, 3,000s, 400s, 2, 3, 4. So let me start writing this in. So I have 20,000, 3,000, 400, 10, 20, 30, 40, 50, 60, 70, 80, 8 tens, and 2, 4, 6, 8 ones, for a total of 23,448. Now let's connect it with the standard algorithm. 19,930. Add that up with 3,548. 0 plus 8 is 8. 3 plus 4 is 7. 9 plus 5 is 14. So I have to carry the 1. 1 plus 9 plus 3 is 14 again. 4, carry the 1. 2, 24,400. Oops. 1, 2, 3, 4, 5, 6, 2. Oops, this was supposed to be 7 tens, not 8 tens. Sorry about that. So this is a good way to make sure you're counting right. So this is a great way to represent it, but in the same way, it's easy to make mistakes when we're using and counting things like that as compared to using our standard algorithm. All right, the last one is 34,548 minus 1,873. So again, with subtraction, I put the first number in, and I'm taking away the second number. So I want to take away 3 ones. 1, 2, 3. I could do that. Next, I want to take away 7 tens, one up, but I can't take away 7 tens. So I have to unbundle one of these hundreds. I'm going to put 100 away, and I'm going to take out 10 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm able to take away the 7 tens I need to. So 1, 2, 3, 4, 5, 6, 7. Next, I need to take away 8 hundreds. I can't take away 8 hundreds, so I have to unbundle one of my thousands and put in 10 hundreds. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And I'm going to take away 8 of those. 1, 2, 3, 4, 5, 6, 7, 8. All right, next I need to take away 1,000, and I could do that. So I am left with 3 10,000s, 2 thousands, 1, 2, 3, 4, 5, 6 hundreds, 1, 2, 3, 4, 5, 6, 7 tens, and 5 ones for an answer of 32,675. Let's connect that with the standard algorithm. So 34,000, 548 plus, this is minus 1,873. 8 minus 3 is 5. 40. 4 tens minus 7 tens we can't do, so I'm taking one of the hundreds and making it into 4 hundreds and making this into 14 tens. Oops, we don't need that. 14 minus 7 is 7. 4 minus 8 we can't do either, so I need to take away one of the 4s. And I need to make it a 3. Cross out the 4, make it a 14. 14 minus 8 is 6. 3 minus 1 is 2. And 3 minus 0 is 3 for the answer of 32,675.